Hello. In this video we're going to use the Pythagorean theorem to find missing sides in isosceles right triangles. And so you can see I have these triangles here, and they're all labeled with two angles of 45 degrees and then the right angle there, which makes them, of course, isosceles right triangles. So in the very top left, if I want to find these two missing sides, and if I call that bottom part, the base of the triangle, we'll say x, well then the other leg in this triangle, because it's isosceles, is also x. There it is. And so we can use the Pythagorean theorem like we've done in the past in order to figure out what x is going to be. And so we can set up that x squared plus x squared is equal to 8 squared. Now I can't do much with x squared plus x squared, as in I can't square x any more than it already is, but I do have some like terms there. X squared plus x squared makes 2x squared, and 8 squared makes 64. So to continue to get x by itself here, to figure out what that's going to equal, I'll divide both sides by 2. So x squared now equal 32. And then we want to square root both sides in order to figure out what x is going to equal. So x will equal, and then the 32, we'll do a factor tree. So 32 is going to be 2 and 16. 16 is 2 and 8. 8 is 2 and 4. 4 is 2 and 2. So we have a pair there and a pair there. So the square root of 32 is going to be, well, 2 times 2 makes 4, times 2 makes 8, times 2 makes 16. So we can look at it as the square root of 16 times the square root of 2. 16 times 2, of course, being 32. So root 16 times root 2 being root 32. Well, the square root of 16 is 4. Still times the square root of 2. So that must mean that each of these sides are 4 times the square root of 2. How about the one right below it? I already know one leg is 3, so that immediately tells me that the other leg is 3. Ha! That makes this way easier. So we just do 3 squared plus 3 squared is equal to our c squared. Or rather, 9 plus 9 is equal to c squared. So my c squared is 18. And when we do our factor tree, 2 and 9, which is 3 and 3. And so we have a pair of 3's. So the square root of 18 is the same as the square root of 9 times the square root of 2, or rather, 3 root 2. And so that's the hypotenuse for that one. How about at the top right? If this leg is already square root of 2, that means this leg is square root of 2. So let's go through our Pythagorean theorem. Square root of 2 squared plus square root of 2 squared equals c squared. Square roots and squares are opposite. They cancel. So I'm left with 2 plus another 2 equals c squared, which means c squared is 4, which means the c we're looking for must be 2. And then finally, the bottom right one. So I don't have any numbers in this one, at least for the sides. But that tells me, I do know that one leg is n. So that must mean that the other leg is n. So let's follow our, so if we do n squared plus n squared, and that's equal to c squared. Let's figure out what c is supposed to be. Much like the x squared plus x squared, we can combine like terms. 2n squared equals c squared. Now I just want to get c by itself, so I'll go ahead and square root both sides. I can square root n squared, and that'll come out with n, but I can't square root 2, and so we'll leave that with the square root of 2 equals c. If we want to consider it like we've done the other ones, it'd be 2 times n squared, which is the square root of n squared, times the square root of 2. This we can deal with because they're opposites, they cancel each other to give us n, still multiplied by the root 2. So that means that n root 2 is the hypotenuse of this. So this is kind of a generic formula or pattern that we can use in our 45, 45, 90, or also known as isosceles right triangles. Whatever the two legs are, they have to be the same thing because it's isosceles, and then the hypotenuse is the square root of 2 times that length. Okay, for now we are done.